Hi guys, welcome back to my YouTube channel Rahman Chemistry Coaching Academy. I am Dr. Tajur Rahman and this is our fifth lecture on stereochemistry. In our today lecture, we will talk about the last two type of structural or constitutional isomerism, that is metamerism and ring chain isomerism. First, we will discuss metamerism and then ring chain isomerism in detail. So, metamerism can be defined as the phenomena in which the isomers have the same molecular formula, same numbers and kinds of atoms, but differ from one another in the nature of the alkyl groups attached to both sides of the same functional group are known as metamers, and this phenomena is known as metamerism. Now, to explain the phenomena of metamerism, let's we take example from ethers, ketone, sulfides, and secondary amines. The phenomena of metamerism can be observed in these types of compounds. These are two ethers compounds, that is diethyl ether and methyl propyl ethers. In diethyl ether, the two alkyl groups, that is two ethyl groups, are attached on both sides of the same functional groups, that is ether functional group. While in methyl propyl ether, two different alkyl groups, that is methyl group and propyl group, are attached on both sides of the ether functional group. Thus, these two compounds are differ from one another in the nature of the alkyl groups attached to either side of the same functional group, that is ether functional group. Thus, these two compounds have the same molecular formula C4H10O, same numbers and kinds of atoms, but differ from one another in the nature of the alkyl groups attached on either side of this ether functional group. Thus, they are metamers of each other, and this phenomena is known as metamerism. Similarly, the phenomena of metamerism can also be noticed in these two ketones compounds, that is diethyl ketone and methyl propyl ketone. Both these compounds have the same molecular formula C5H10O, same numbers and kinds of atoms, but they differ from one another in the nature of the alkyl groups attached on either side of this keto functional group. Thus, they are metamers of each other. These are the two other examples in which the phenomena of metamerisms can be observed. These are two sulfides compounds, that is diethyl sulfides and methyl propyl sulfides. Both these compounds have the same molecular formula C4H10 is same numbers and kinds of atoms, but they are differ from one another in the nature of the alkyl groups attached on either side of this sulfide functional group. Thus, they are also metamers of each other. The phenomena of metamerism can also be seen in secondary amines. These are two secondary amines, that is diethylamine and methyl propyl amines. In both these compounds, they have the same molecular formula C4H11 in same numbers and kinds of atoms, but they are different from one another in the nature of the alkyl groups attached on either side of this amine functional group. Thus, they are metamers of each other, and this phenomena is known as metamerism. The last type of structural or constitutional isomerism is the ring chain isomerism. The ring chain isomerism can be defined as the isomerism in which the compound are having the same molecular formula but different in the mode of linking of carbon atom is called ring chain isomerism. The ring chain isomerism may either be open chain are closed chain structures. For example, these are the two examples of the ring chain isomerism. In the first example, that is propene and cyclopropane have the same molecular formula C3H6, same numbers and kinds of atoms, but they are differ from one another in linking of the carbon's atoms. The same phenomena of ring chain isomerism can be seen in profene and cyclopropene. They both have the same molecular formula C4H8, C3H4, same numbers and kinds of atoms, but they differ from one another in linking of the carbon atoms, and thus they are ring chain isomers of each other. Same is the case with butene, but1-ene, cyclobutane, and methyl cyclopropane. These three compounds have the same molecular formula C4H8, same numbers and kinds of atoms, but they are different from one another in linking of the carbon atoms, and thus they are ring chain isomers of each other. This is another example of the ring chain isomerism. These three compounds, that Higgs 1-ene, cyclohexane, and methyl cyclopentane, have the same molecular formula C6H12, same numbers and kinds of atoms, but they are different from one another in mode of linking of the carbon atoms. Thus, they are ring chain isomers of each other, and this phenomena is known as ring chain isomerism. So, this was all about metamerism and ring chain isomerism. If you find my video interesting and informative, then please like, share, comment, and subscribe my channel.